Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event today by thanking Pivotal for sponsoring today's event. Pivotal is a wonderful partner and supporter of the Data Science Central community, and we are very honored to have them sponsoring today's event. I would also like to take this opportunity to mention and show our recent support of other webinars and sponsors including Tableau, MarkLogic, TIBCO Spotfire, Hortonworks, and Splunk, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you have not had the chance to check them out, I would encourage you to do so, as they do provide some very useful information. Today's webinar is entitled Accelerating Big Data. Before we begin, I'd like to briefly review the format for today's event. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a moment. We should have about 10 to 15 minutes for Q&A following the presentations. And as always, this event is being taped and will be made available on demand at Data Science Central later on today. I would also like to encourage our attendees to provide questions directly to me throughout the presentations. I will be reviewing them and presenting them to the presenters at the Q&A session following the presentations. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce our moderator today, Dave Menninger of Pivotal. Dave is the head of business development and strategy for Pivotal. He has also worked as VP and research director for Ventana Research with stints at Vertica Systems, Oracle, Applex, InfoSense, and IRI Software. Today's panelists are Scott Jarr of VoltDB and Mark Palmer of TIBCO Streambase. Scott is the co-founder and chief strategy officer for VoltDB and is a technology visionary. He started the company in 2010 to build a new generation of applications that act on data at its point of maximum value. He has an undergraduate degree in mathematical programming from the University of Tampa and an MBA from the University of South Florida. Mark Palmer is going to be with us today sort of virtually. There was some conflict, so he had to attend another event. But he is going to be here with us as a videotape and being supported by Jonathan Gallagher and Eddie, who are both part of the company and will be available for additional questions at the end of the presentation. We've all come to know that big data is generated constantly. If you wait to process big data in batches, you will likely miss a critical opportunity to react and to respond to events as they are happening. As the volume and frequency of data has accelerated, so have the strategies to deal with real data in real time. Today, we'll learn how businesses are processing big data as it occurs and the value it can create for your organization. So Dave, I'm going to pass the presentation on to you so you can begin. And you should be set to go. You all set?
I am all set.
There you go.
And you should be able to see my screen now.
Yep.
So first of all, Tim, thank you for the opportunity to participate in today's webinar and to speak with the data science community, and thank you to the attendees for participating. Our objective this is a series of webinars we've been hosting, and our objective is to share information that hopefully the audience will find useful in trying to understand some of the aspects of dealing with big data and what some of the potential solutions are for processing that information. My role today, I'd like to give you a little bit of background about who Pivotal is and why we're sponsoring this event, and then I'm going to hand it over to our partners to talk about their approach to this part of the market. So Pivotal was formed on April 1st. It's an organization that was constituted out of parts of VMware combined with the entirety of Greenplum. Greenplum also included an organization called Pivotal Labs, and so those three entities have combined into what's called Pivotal, which is led by the former CEO of VMware, Paul Maritz. And our focus is really on delivering a platform as a service capability to enable organizations to have a platform such as the one created by the internet giants. When they created their platform, the Googles and the Facebooks and the Amazons, there was no platform they could purchase to do the scale-out processing they need to do. Our goal here is to make that type of processing available to enterprises, to be able to purchase an enterprise platform as a service that delivers those scale-out capabilities, really focused on a simple notion. We're trying to enable applications that deliver big, fast data in cloud-like infrastructures, whether those are public cloud providers or private clouds, hosted in your data center. But the point is the elastic scale-out nature of a cloud and delivering an infrastructure on top of that for big, fast data. The portions of our portfolio that we bring to the table are listed across here. We've been in business for a number of years, have thousands of customers. We'll be generating hundreds of millions of dollars in revenue this year. We've stated that publicly. And the products are listed across the bottom here. But what might be a little easier to understand is sort of the macro picture. We look at our offerings as dividing up this enterprise platform as a service capability into 3 layers. You need to have a cloud fabric, a data fabric, and an application fabric. And I've listed our offerings in each of those areas here on the sides of the screen, and we're not going to go into those specifically today, but just to give you a sense of what we bring to the table. And one of the key notions of what we're trying to do is to deliver those things in a cloud-independent way, so that if you develop an application to run on Amazon, you could bring it in-house, run it on VMware, for instance. Or if you want to move from Amazon Web Services to OpenStack, that we would enable that capability. And that's a challenge in today's world. So that's part of what we're trying to do. The other part is really to enable organizations to take full advantage of the data that they collect and generate in their organization. And we could go into a whole separate discussion on what are the types of analyses you might want to perform over big data, but we'll save that for another day. And in fact, you can go back and look at some of the archives and some of the data science presentations we've done in the past with the data science central community. But today, what we're really focusing on is the data fabric and the partner ecosystem that works with that data fabric. And so, we have assembled a platform out of the parts that I described previously. And in order to make that platform as valuable as possible, we know we have to enlist the assistance of partners and build out a healthy partner ecosystem. And so that's really what this webinar series is about, is who are some of the partners in that ecosystem, and what are their capabilities, how do they add value to the fabric that we've created for the underlying storage and management of this information. And Tim's comment is appropriate. When I'm meeting with customers and trying to educate them on big data and the way in which it's changed our thinking about information processing, I think fundamentally there's been one change that really is at the heart of this, and that's the movement from data being generated by humans sitting at a keyboard to data being generated by machines. And if it's being generated by machines, it's likely that it's being generated 24/7. And as that information is generated, there's presumably an opportunity to utilize that information as it's being generated. And in fact, if you're not using that information in a real-time way, it's likely that some of your competitors are. And so today we want to talk about what are some of the ways in which you can deal with that information in real time, and how might you take advantage of that information that's being generated in real time. And some of you may think that it's not relevant in your business, but presumably all of you have a website, and all of you have people visiting that website and navigating around that website. And so there's one simple example that's pretty universal in terms of trying to take advantage of real-time information. There are many industry-specific examples. We'll hear some of our panelists talk about those today. But real-time processing of information is really becoming pervasive in the market, and we want you to be aware of how you might take advantage of it. That's all I'm going to say about Pivotal. You can get more information about Pivotal at gopivotal.com, or you can follow us on Twitter at @gopivotal. And so we'll turn the presentation over now to Mark in his recorded voice, but we'll turn it over to Streambase for their addressing of this real-time requirement.
Okay, thank you for that overview, David. Give me just a moment here as I transition here and launch.
We all know that there's lots of excitement about big data. It transforms the way you think about information because you can get so much more of it. But one of the things that is very common is that a lot of firms that are in this space are really all about accumulating it and analyzing it rather than actually operationalizing it. You know, it's really good if you get a bunch of historical information and figure out what happened already, but at Streambase we really focus on what's happening right now, what's happening in real time, what pieces of information can you get out of big data that can help make you make better decisions in the instant, that can help make you better decisions by automating processes that might have been manual before. So the way we think about this is that, you know, we've got historical insight, which is really well covered by lots of products in the industry, to figure out, you know, have I missed my profit targets? And if I've missed my, how do I automate and change the way your systems are behaving, change the way you're offering offers to users when they're in the store, before they left the store, or when they're on your website, in real time, in the moment. And those are things that you can figure out through tools that are focused on real-time analytics, like, of course, Streambase's. So the way we look at this is you've got some historical insight. You might adjust your automation models in event processing type tools, deploy those, and then analyze the results, reanalyze the results. So you get this closed loop effect, which is very, very powerful. This is, I think, the next stage of big data analysis that a lot of the leading edge firms are starting to do. And then when you do that, you can actually see, okay, well, I've adjusted things, and my profits are up, but my margins are off. Now, why? So I can go through that loop again. So this is really kind of the end of the big data challenge that we focus on. And this is the bulk of the back end of this presentation, which is really about how do you achieve that. And we see two parts of this. First is the architectural elements, so the need to connect to big data with a historical reservoir, if you will, and that's where tools like Hadoop and a lot of data warehousing technologies are very strong. Then to connect to big data with a real-time coprocessor. Real-time coprocessor is this concept that our customers have come up with, that where they think about Streambase really as this processor that sits alongside the historical reservoir, taps off from it, and then does their automation logic there. Architecturally, we really need to augment the existing infrastructure, don't replace it. The user interaction model changes. It's not sort of, I'm in a tool and I grab a bunch of data and I analyze it. That's really the sort of the historical way of thinking. Our model is really more push-based. That complements the traditional way of looking at historical data. I'll give you a sense for that in a minute. The other thing that becomes very prominent when you start operationalizing off big data is how to alert users, to command attention where it's necessary. You're really talking about narrowing down 1 billion of events a day that may be flowing through this big data infrastructure to the 100 or so that really matter that you need to act on in the moment. Now, the practical things that we think about are how do we deploy and evolve, maybe more importantly, evolve those big data solutions very quickly. So figure out what patterns you're looking for, deploy them very, very easily, and then evolve them over time. Of course, scalability has to be built in from day one, and you have to connect to every other system in the ecosystem to make sure that you can actually operationalize and automate off the insights you get. So the reference architecture that we have come up with here with our customers is where data is coming in from the internet. You attach to it with technologies like VoltDB, capturing information and connecting to the rest of the enterprise via something like Flume, which is an open source project that Streambase is integrated with. And you wind up having this red and orange path up top. That's the historical path, right? That's the I'm looking at what happened in history. And down in the blue, you see messaging by TIBCO and Flume, of course, feeding into the Streambase infrastructure, and then Streambase LiveView over on the right in gray. This is really the operational path. This is what you're doing here for automating. You're looking for decisions to make about perhaps fraud detection. If you find phishing attacks or financial transactions that look incorrect, you can make a decision in real time to adjust those user accounts, maybe turn them off, maybe alert them to a fraud detection group, which you see down way below, maybe send alerts for really important, potentially fraudulent events to fraud detection staff or an operational staff that can investigate further. This is a very common use case we're seeing in really real-time commerce applications and fraud detection type systems and regulations, particularly in financial services. Up top, we've got a lot of technologies that were here hosted with Pivotal today. Green Plum technologies, EMC technologies. These are all dealing with that. What's happened? What's happened in the past in my big data reservoir, if you will. From the Streambase side, we really attacked the problem with two main products. One is Streambase LiveView, that gives you discovery and insight in real time, so a dashboard that's constantly updated in real time. And then, of course, Streambase CEP for advanced analytics and automation. And I'm going to give you a quick sense for those products right here. The overall stack is we've got data coming in from the left, decisions and outputs coming in from the right. This is all real time. The system's designed to really process all that information, all those events, looking for important automation opportunities in real time in the middle with Streambase servers and data management and log connectivity down the bottom. But first, I want to talk about Streambase LiveView. Streambase LiveView is a product that we've designed that really allows you to take your real-time flowing data and make it look like tables, but with a push-based mechanism. You can see in this picture here, you submit, there's a product where you submit ad hoc queries, just like you would to a database, to the server, which has a continuous query processor model. So this continuous query processing provides a snapshot like you normally would get from a database, but then the question keeps being answered millions of times a day. So you're looking for these conditions that are important, and the user is being pushed updates live in real time. You'll see this very quickly in a short demo in a moment. The other thing that the continuous query processor mechanism allows you to do is set up alerts where you can get very high priority alerts sent to users proactively. So the desktop looks like a lot of other desktops, graphs and charts and tables of data. What's different is what you see here on the screen, which is the data in a LiveView desktop is constantly live. You can see the table here being updated, colors changing. Those aren't this isn't a demo that we're showing you where the user's sitting there hitting the refresh button, right? This is the mechanism, the physics of Streambase and Streambase LiveView, where when you ask a question about one of the most important stocks, or one of the top performing stocks, in the system right now, you actually get that view constantly updated. And this is a view that we can not just have in a sort of tabular view, but also a graphical view with charts and graphs and the things you expect in sort of modern desktop experiences. So the benefit of Streambase LiveView is to provide this analytics environment so you can visualize information, but you're always seeing the live data. It's data that's up to the almost literally millisecond. This allows you to see and gain insights very quickly as to what's happening in your operationalized systems, and then get into market very quickly because it's got a whole bunch of pre-built connectivity to the existing infrastructure. We have over 150 connectivity points, adapters that connect Streambase and Streambase LiveView to the rest of the enterprise. And the whole point of this is not just to see what's going on, but to do something about it. So this is the whole concept of anticipation, so anticipating what operational conditions might be important. And then when Streambase and Streambase LiveView detect those conditions, then to take action. the actual way that these advanced analytics on real-time data are authored is our Stream-based Studio environment, which is a graphical environment that's very well known in the industry, where you literally can build these applications, these analytics, in days rather than weeks or months, and maybe a month instead of a project that would have taken a year with traditional sort of static-oriented technologies. And that's all about Stream-based. It's an agile development environment that allows professional developers, IT, as well as quants and even business users get involved in seeing what the logic is, because it's all about automation, right? So you're trying to figure out what the appropriate algorithms are to automate off of. Performance and scalability built in. Like, a lot of people know that Stream-base's background in the capital markets and dealing with some of the largest flows of events that exist in the world, really. And again, a pre-built connectivity and third-party integrations. But what's changing with our new home at TIBCO is getting expanded reach to other use cases outside capital markets, things like in the retail industry, cross-sell, upsell, more fraud detection, risk management applications, telecommunications, gaming, applications in energy for sort of smart grid and monitoring and controlling and automating what happens as data flows through that smart grid as well. So that's pretty exciting for us here at Stream-based as we expand our footprint in the global technology market space. So thank you for having us join to talk a little bit about real-time big data analytics. And with that, I'll just say thank you, and contact us for more information on how we process real-time data.
Bear with me just one moment. I'm going to transfer the presentation over to. Sorry, there's a bit of an echo. By the way, I neglected to provide Mark's background. So for everyone's benefit that they just heard speaking, Mark is the VP and General Manager of TIBCO Stream-based. Yeah, he has over 20 years of experience in the financial technology industry with expertise in algorithmic trading applications and automated trading architecture development. And he speaks frequently at various trade events and is quoted in many publications, including the Wall Street Journal, Time Magazine, and Financial Times. So my apologies, I forgot to mention that at the beginning. So with this next transition, Scott, I think you're good to go.
Excellent, thanks, Tim. I assume you can see my slides here?
Yep, looks good.
Fantastic. Well, thanks to my friends at Stream-based, as well as EMC and you, Tim, for hosting this, and for everybody attending. I'm going to walk through a little bit of VoltDB, and I think one of the things that that I'm really thrilled to see in general, and we see it in this webinar here, is that vendors in the industry are talking about a lot of things that are very consistent now. One is education. This has been a very confusing market for all of us, and having been in this since the early days of big data, along with everybody else on the phone here, I think we're all glad to start to see some real rationalization come here. I will spend time talking about how we view the market, and I think it's very much complementary to what David and Mark both said. And the other thing that I'm very pleased to see is that we all talk now about ecosystems, and the fact that no longer are all these problems in data are being solved by a single data store. And that's very much evident in what we've talked about already up to this point. I'll spend additional time talking about that. So from a VoltDB perspective, I do like to kind of set the ground a little bit here. We believe that, David said it great in the beginning, big data is a huge thing. You know, people often ask me, I also do a lot of speaking and talking to customers as well as just generally to the market, and people always ask, don't you think big data is overhyped? And the reality, I think, is that it's completely underhyped. We're just now starting to experience what this is going to look like as it starts to roll out, and we're at the very, very early stages of it, and it's going to be transformative. This is amongst the size of markets that were client-server, that were network, that were software as a service, cloud-based, and now data is going to transform the world into a market of that magnitude. So I think there's a lot going on there. And again, as was mentioned earlier, fast data, we call it velocity, but that's becoming the key piece to this puzzle in many ways. Certainly there's a lot that needs to happen in the back end with analytics and a lot with Hadoop, and there's just a lot of interesting things going on there. But fast data is certainly driving the volumes that we're starting to see. And as we have said, and I continue to say here, is that the one-size-fits-all database are gone. We have specialized databases, whether those are Greenplum or VoltDB or Streambase or Pivotal HD. There are a lot of databases that are solving very specific needs, but they all have to work together. And when we look at a data pipeline, and I'll have a little example in a little bit about how some of our customers are deploying these products into a data pipeline, we really start to get a picture of what this market looks like. And a last point that I'd like to make here is that I believe, and I'm sure our audience on the phone would probably tend to agree with this right now, we're done with the days of people just experimenting with these products to see whether they're interesting or whether they might be able to come up with something on them. Businesses today are being drawn to the values associated with big data, whether they're fast data problems or analytic problems or stream processing problems. It really doesn't matter. Customers see very tangible value, and they're looking for those projects to provide value very quickly within the organization. So with that, I think we have the dawn of the beginning of this new data environment, which is very interesting. But one of the things that I continue to see is a lot of confusion, as I said in the beginning. And we've spent a lot of time talking to the market in general and customers specifically about how to look at the market in terms of all these various products. And as Mark did, I'll have an architecture slide, very high level, in a little bit. But I'd like to step back for a second and really look at the entire ecosystem sort of along a timeline. Because I found that this way provides a little bit more clarity to people than trying to list product characteristics and figure out where things go. We started looking probably a year and a half, 24 months ago, on data, not in terms of what the database capabilities are, but very much in terms of the age of the data along a continuum. So on the left-hand side of this little chart here, things get created. Data is initiated. Oftentimes it's machine-generated. Sometimes it is web-based. There's a lot of things being created very quickly, place trades, sort of ads, things that are occurring very fast. It's interactive. And then time moves on. We see a huge push right now into the real-time analytics. Mark spoke quite a bit about that, and into record lookup, and then which I'll sort of briefly go over. But more importantly, I want to dive into this historical analytics and exploratory analytics, because those are the two phases that we're starting to see the market fall into. Is this very much this interactive real-time analytics phase and this historical deep processing analytics phase. So you can start to see, and I know there's many industries and with many use cases on the phone here, so I don't want to focus too much on any particular one. We're deployed broadly across many of these markets, but you can look into these little bullets at the bottom and start to see some of the ideas that we think about when we look at these particular use cases. So where we place trades in an interactive sense, we might be looking for fraud pattern matching on the far right-hand side in exploratory analytics. And I can go through some use cases, and I'm sure some will come up in the question. But where this becomes very interesting is when you look at the value that this data represents to an organization across this timeline. And I have two intersecting lines here. The first one that starts high on the left is the value of data at an individual item, which degrades very quickly, actually, as time starts to move on. And we look at it in real-time analytics, that data has some value, but when we get to exploratory, there's very little value in a single data item. Yet when that data is created, it is of its utmost value for that one particular piece of data. And we see the converse happening as we look at the aggregate of data. It's kind of common sense as you start to look at it this way. But what it gives us is a bit of a framework where we can now start to overlay. We'll take this graph here, and we'll overlay database products onto this. And this is where we start to understand where these products might fit. Traditionally, in the old school format, the traditional database went to solve all these problems. And as long as things were simple, slow, or small, in any of those types of characteristics, things were fine. As soon as they got to be fast, as soon as they got complex, or as soon as they got large, that's where you started to see the traditional database no longer able to solve that problem. So that's where we've seen things like Hadoop and analytic stores coming out. We see data warehouses presenting a tremendous amount of value in the historical space. And on the far left-hand side, we're starting to see very much this new SQL category, or we're terming the high-speed part of this, the velocity use case. So now as we sort of look at a market here, we can take virtually most of the databases that we see in the industry and plot them somewhere along this graph to start to provide a little bit more context to people so that they can figure out where things fit within the system. And now let's take that concept and really move it over to a bit of an architectural drawing. And when I talk to our customers, and the things that I'm seeing in the market is really they're looking at a question in their mind of, how do I make the most informed decision every time I interact with a piece of data? So an event comes in, whether it's a credit card transaction, a capital markets piece of tick data, or whether it is a request to serve an ad, on every single interaction, they want to make the most informed decision possible. And so they have these things on the left-hand side here that are coming in at thousands to millions of events per second. We need to ingest that data. Decisioning, we used to call that in the old days of databases transactions. Very much a transactional system where we're trying to make a decision on a very particular piece of data that's coming in. And then I'm analyzing that in relation to a lot of history that I have, but yet not my entire set of history. So I'm looking at history to provide some context into real-time analytics, and I might be using those real-time analytics in making the decision. So, for example, I might be looking at how do I place trades, or I'm sorry, how do I place ads on an ad trade platform where I'm looking at historical, the last 60 minutes of trade activity to determine what's the best exchange to place an ad on. So these are the types of things that people are looking at Volt to do, and I'll talk about some use cases in a moment. But I want to frame the picture here where we start to look at how does it fit into the larger ecosystem where we have things like Pivotal HD and Greenplum that are really supporting the historical analytics and the exploratory analytics. I don't want to try to talk to what wonderful things Pivotal's doing with these products, but in general, these little boxes on the side here kind of give the ideas. And what we're seeing in our customer base is very much these lines of data flow that are going on. So authorizations and sensor readings are coming into Volt. We're doing ingesting those at the very high levels, storing them on in memory for transaction processing, decisioning. We're doing real-time analytics on them, and oftentimes we're then handing that data off to another store. And whether that store is directly to something like Pivotal HD, where the raw events might be going to be stored for very long periods of time, or whether that data gets pre-processed ahead of time. In other words, we're no longer doing the ETL as a land in batch and read that back up and try to ETL it. We're doing a lot of ETL on the fly so that we can be handing pre-processed data off to a store such as Greenplum. So you start to see here an architecture that is very consistent across our entire customer base, where you're running analytic stores in combination with Hadoop, and you're also running a transaction store in the front end. So, and I will echo something that Mark said. It's a very interesting dynamic that we're starting to see exist very broadly within the market. It started initially as people doing it manually, but it's the idea that we learn so much. There's only one reason to do analytics ever, and that's to make better decisions. So what we're seeing people do is we're seeing the Pivotal HDs and the Greenplums creating more knowledge within an organization that is then fed back into the transactional system that sits in the front that's actually ingesting every single event. And then that knowledge is driving better decision-making process. So I can use a composite risk profile in a capital markets event that I've determined via VoltDB to make better decisions on each individual trade that's occurring. So what are the characteristics that that exist within that high-velocity use case area there that Volt is really seeing? And it's quite simple from our perspective. We see really three characteristics. And the first one is the fact that we're dealing with event streams that are coming in that are far beyond what a traditional database would ever dream of really handling. So our customers are dealing generally in the 1,000 transactions per second and up into the millions of transactions per second. So these are very high streams. Dave said it in the beginning, very often these are generated by some sort of machine, whether it's sensors or whether it's web logs on networks or whether it's tick data in capital markets. They're coming in relentlessly, and it is 24/7, and it is what's generating the large amount of data in the back end of the systems. But our customers are also looking to make a decision on each one of those data, and that decision is a transaction. And in traditional database lingo, there were reasons that we did transactions the way that we did, and a lot of those reasons remain valid. But what we see becomes very challenging is trying to make those decisions on data that's coming in at the kind of staggering volumes that we see today. And these volumes are, as Dave said it perfectly also, it's not that it occurs in very rare use cases. This is across almost every market that we see today. We have use cases that are broad spectrum right now because so many companies are looking at that huge strategic value about making decisions on that fast-moving data. And then the real-time analytics is the other piece, is the third leg of this stool. And very much two phases to this. One is human visibility via dashboards. People are very interested in taking the ability to see what's going on and allowing human operators to interact with that data in a way that they can make determinations and make human-based decisions. But equally important, what we're seeing is we're seeing these decisions being driven by automated decisions. So how do I use the level of analytics and the SQL capabilities in a very fast-moving real-time analytics situation to make better decisions in that transaction process? So the example that I gave earlier on the real-time risk is a perfect example of that. That's a very database-intensive application where I'm looking at some history, I'm calculating things, and I'm making decisions in real time based on that so that I can stop things from happening or allow things to happen in the flow rather than it being a forensic process to try and go back in the future. So again, very much use cases that fit together where we see a front end that's dealing with fast data and a back end that's dealing much more tightly with analytics, both from report generation as well as exploratory analytics and some of the very interesting things that are going on in those capabilities. So having given an overview of the use cases and where we see, I did want to jump in and give a little bit of meat into what the technology is. A short presentation like this doesn't afford us to go deep into technology, and I'm certainly not the right guy to do that anyways. But I do want to give a bit of grounding here for those of you that are starting to think, well, geez, what actually is this product? It's a high velocity, it's an in-memory database. We leverage data across, or memory across many cores and many servers within a cluster. It ingests data in real time, as I said, and we have produced a system that provides durability to disk. So while a lot of the in-memory databases that have characteristically existed were single machine and they provided durability via a separate database, Volt's providing that all together. So it's an in-memory database with built-in durability across disks. It's also relational, ACID, and SQL compliant. So it is a database. To a database developer, it looks very much like a traditional database. There are reasons to do this. We have, in the applications where Volt is focused, SQL becomes very much an advantage. It's a skill set people are familiar with. It's a capability that allows a lot of that complex data management that is required when you're doing more complex systems. In a NoSQL system where it's very much a record lookup use case, that capabilities of SQL are not nearly as important. But as you start to look at the data use cases and the real-time analytics together that are driving these velocity use cases, SQL becomes a very key tool that allows people to do things much more efficiently. And it is a relational system. So for all the reasons that you might like to have a relational system in your back end, like a grain plum, you're going to want to have a lot of that same capabilities in the front end system. And lastly, from a technology perspective, it's a scale-out system. So we have seen in the market scale-out commodity hardware pizza box systems replacing all the monolithic hardware out there. There's hardly a single database infrastructure tool today that is not a scale-out and replacing the monolithic system. So Volt is no exception to that. Scale-out systems give you a lot of great advantages. Obviously, you can scale, in our case, both processing power as well as memory. And you can, congregate memory across as many machines as necessary to get that kind of high velocity use case as well as larger memory sizes. But it also gives us the ability to have built-in failover, built-in replication, and it also becomes a very flexible deployment model where deploying it in the cloud becomes very natural as soon as you start to think of a scale-out system. And in fact, the way Volt works is we scale out on cores within a system. So now you start to see where it can be very advantageous to take something that's either on dedicated servers or it's in a virtualized environment on VMware within the enterprise, or it becomes cloud-based. It's a very simple process to use both the capabilities of Volt as well as that cloud-based virtualized system. So with that, I'm going to just spend a couple minutes here on some of these frequent applications that we see in the market. There are many more, but I wanted to, I always find in webinars like this where there's such a diverse audience, it's good to kind of throw up a lot of them so that people can see the ones that match their requirements and their uses. Very much markets that you would assume. I think probably a lot of folks on the phone are in these very specific markets. Telco is a very big one. We're doing a lot in billings and rights management. We're dealing with inbound data feeds coming in very fast where decisions have to be made on a CDR record, on a call initiation, on a request from a mobile device, managing all those things, providing real-time analytics, and we're very much, again, in this use case, always moving that data off to a store like Pivotal HD or Greenplum. Energy and sensors is another one I'll point out. I think it's a very interesting use case. It's quite frankly one that I did not expect to see in the volumes that we see today. It was seemed to be an early market where we're still just talking about the sci-fi-ness of having smart grids and smart sensor networks, and yet there are tremendous amounts of deployments of these going on. California has a very large smart grid, smart metering system in place. We're seeing that across the globe. We're seeing very interesting things where companies are using both sensors on mining equipment, both physical equipment as well as humans in the mines. These sensors are providing tremendous amounts of data back to a system, both ingesting that data, and it's allowing them to do things in real time, such as determining where there are a congregation of human sensors where the CO2 level has risen to an unsafe area range, and making in-the-moment decisions to say those guys are in danger, get them out of there. So very much real-time decisioning, things that you wouldn't go and run a back-end Hadoop query against, because that data, by that time, those guys are in a serious problem. But there are a lot of capabilities within that exact same use case where Hadoop and Greenplum are providing different levels of value. So again, we're starting to see customers really understand the differences and how these things work together in that data pipeline that I showed you earlier. And one last thing that I think I'll touch on here is a couple use cases in the infrastructure side that's often interesting to people. We talked about the data pipeline in the beginning, but also this migration of batch processes to real time. There have been a lot of batch processes that exist in the enterprise today, quite frankly, because there was no way to do them before. We landed the data on disk, we read it into a system, we tried to do some processing on it, we did permutations on it, and then we went and tried to land it into another system. There's no reason if that data is coming in fast that we can't do that processing on the fly. And we have quite a few customers that have moved from that. Number one, their original reason to move from that is because of the operational simplicity. It takes a tremendous amount of cost and complexity out of the system. But then as soon as you get past that point and realizing the value of that, you realize that now I can start to do things in real time. I can make real-time decisions. I can look at real-time analytics. And then the value of that application just gets much higher and much more strategic to the organization. So with that, I wanted to give you just an overview of some of the use cases, and I'm going to hand it back to Tim and team, and hopefully we'll hear from you with some additional questions at the end. So thank you very much, Tim, and back to you.
Great. Thank you, Scott. That was a really very thorough and very interesting presentation. So we do have time for the question and answer session, so let me just transition this back to me real quickly here. Just a moment. So during the presentations, there were some questions coming through. Thanks again to the audience to appreciate your participation. And during this Q&A, you'll notice that the current slide that's up provides Dave, Scott, Mark, and Eddie's contact information. Please feel free to take down their email addresses, and you can contact them after the webinar if you have any follow-up questions. So one of the questions, Dave, I think I'm going to pass this one to you. So it seems to maybe provide a good starting point in terms of tying things together. The question is essentially, can you provide some detail about what a typical system configuration might look like? You know, is there memory requirements, core server, cores per server, what type of network fabric, et cetera? So I'll let you field that.
Well, actually, I think it's probably more appropriate to give to our partners. I mean, we're in this scenario, we're talking about the information ultimately landing on Hadoop or Greenplum database, and you know that I think that cluster of machines is a separate cluster typically from the ones that are processing the real-time information. So I guess the first comment I would make is that I would ask our panelists, I assume that the configurations they're talking about are dedicated clusters for handling the real-time information, and you know, maybe they can describe what those clusters typically look like.
Yeah, sure. So this is, oh, sorry, Eddie.
Sure.
I'll answer.
Go ahead.
I'll answer really quickly from Volt. So Dave's absolutely right. These are typically dedicated clusters. We'll see a cluster for Volt, a cluster for Greenplum, and then potentially a cluster for Pivotal HD. Our clusters are typically not that large. The kinds of processing that we get done in a single machine is in the order of you know, tens of thousands of transactions a second. So it's not unusual for our clusters to look like under 20 nodes of dual quad-core machines. They're really just gig-E and networking between them with, you know, 128, 256 of RAM in each one. You know, very standard off-the-shelf type of hardware.
Yeah, on our end, that's Streambase. So there are, as you remember from the slides, there's the event processing Streambase product as well as LiveView. They have slightly different demands. Streambase CEP event processing is generally about low latency. That's usually been the play there. What we favor there are actually large amount of cores, 24, 48 core boxes, because our clusters, we will almost prefer actually, if it can be done on one node, that's great. That just delivers the total lowest latency. If you partition and try to and use more hardware, what's typically done is kind of data processing lanes where you'll partition the data. Sort of, let's say in capital markets, you'll take all the symbols, you know, high volume symbols, or perhaps all the ones starting with A to L on one machine and the rest on the other. But we love to use lots of cores. 24, 48 is actually some of the more recent configurations. LiveView, being more of an in-memory store, indeed similar to the VoltDB, is in the 128 gig sort of memory configurations. Smaller clusters essentially than some of the other offerings here, but generally, again, you know, that's one way to scale. But in general, Streambase tends to try to use as many cores as we can on a dedicated machine.
Okay, very good. Here's a question for Scott at VoltDB. And the question is, how does VoltDB move data to the Pivotal database?
Yeah, good question. We have, I think that was an area that we always knew that was going to be a requirement to move data between the systems, but as we've really gone to market, it's become much more intense with what customers need to do. And so we've built a lot of capability into Volt that allows us to not only ingest the streams that are coming in that fast, but batch them up in a way that it's either processed or raw data, and batch them up such that it's in a way that is consistent with how Pivotal HD wants to ingest that data. So we have an export system built into the product that will map and match to what the Pivotal HD wants to receive from a data perspective, and then manages buffering and control of that data to ensure that data is being landed within Pivotal HD prior to it being deleted from VoltDB. So it's a very much built-in, hands-off export system that integrates the two products.
Okay, very good. This question is for Eddie and Jonathan. During Mark's presentation, there were a few questions that were coming in about the visualization and the desktop options. So can you maybe speak to a little bit about the additional visualization options that exist for this Streambase Live View?
Yeah, sure. So, out of the box, Live View does come with a client. So stepping back, there's been obviously lots of products, lots of history around analysis done in visual tools, right? So kind of your BI tools, which have developed a tremendous library of how to chart, how to look at large volumes of data. LiveView was starting something pretty new about actually presenting real-time data to the user, and what we set out, we had to build our own visualization product to get users really started. So there is an offering that comes with LiveView that taps into LiveView and presents, as you saw, live charts, live tables, etc. Now, what we really do, Streambase as a company, is primarily about the processing, about the data crunching, and what we then have are APIs. So essentially, if you have, or wish to build out, be it in .NET, Java, HTML5, JavaScript, what we have there are APIs, and you can think of our off-the-shelf desktop client as one of the implementations of those APIs. So out of the box is an experience available. We found 50-50. Some customers really integrate it with any particular. Usually they have a front end that the firms are building out already. This is common in capital markets, especially where there's already a centralized kind of dashboard technology already in place, and we will just wedge in there to complement whatever visuals are there today. Looking forward in the future, so you saw a reference to TIBCO Spotfire visualization tool. In the future, not to tease too much, there will be more synergy and integrations between a historical analysis tool and a visual technology such as LiveView. So that's, in essence, that's a client available, but a lot of APIs. If there's a message here, right, throughout this entire presentation, it's about having APIs, about having connectivity to various platforms, products, data fabrics, and for visualization, it's the same thing. We just have to be ready to connect to what customers might have or what they might be building.
Okay, very good. This question, I think, is possible for all three of you to respond to, but Dave, I'm going to ask it of you to start. How do you achieve high availability and durability?
Well, I mean, one mechanism for durability certainly is that the information gets written out and we have the historical record. I mean, I think there's a different question as the information is being processed. Should there be some sort of failure, I guess we need the partners to describe how they would achieve high availability. High availability in the historical store is accomplished by having multiple records of the data on different nodes. I suspect that we would hear from the other folks that that's what the mechanism they use. I guess it gets a little more complicated when you think about these things being in memory. If you lose power on the cluster, how does that impact high availability? So why don't we start with Scott? Scott, how do you deal with those kinds of issues?
Great question, and I think that's one of the things that has hampered in-memory databases for a long time. So we've spent a lot of time on this problem, and there's really four phases that we go through in providing availability and durability within the system. The first, as I mentioned when we were talking, is availability. So Volta, being a clustered system, has high availability built in. You can choose how many versions of the data exist on that cluster, and it will be replicated seamlessly across as many of those servers as you want, and any of them fail and there's just high availability. It looks like the old tandem style systems. The system keeps running. The second is snapshots. So we will take periodic snapshots of the entire data set, put them to disk, and that will be a basis for somebody to go back and recover that data in the event of a power outage, for example. That is often not enough for our customer use cases. So our customers have also looked for a feature that we have that's called command logging. And command logging takes every individual transaction that hits the system, logs the instantiation of that transaction to disk for durability purposes, and then commits the transaction. So we go from availability where it's an HA system with failover to snapshots where it's persisted on disk at certain time intervals to real-time persisting on disk via command logging. And then naturally we also have a wide area replication strategy where you can move that data in an asynchronous fashion from the local system off to a remote system. So very much the things that in the traditional database world you have to add on and add on and add on to get those capabilities. With Volt, they're sort of integrated into the core system.
And Eddie, what about in the Streambase architecture?
Yep, in the Streambase architecture, typically we, as you've heard, and we're more of an in-memory store, generally operating against a copy of the data. So if you go back to you can picture the architecture slide we had before. The raw data is going into some storage cluster, say Volt. After that, what you're doing is generally sending a copy, if you will. One end goes to a Hadoop cluster for everything that will do, and then at the same time you're kind of sending off a copy to a CEP engine that's going to be crunching, and a live view instance that might be storing just the last hour so somebody can look at it, or maybe the last day, but not all the history. So we actually cooperate with the same kind of data fabrics that are being discussed here. Generally speaking, if a bus is available, that will be, many buses have features such as checkpointing or being able to replay and request a replay. Essentially, Streambase offers actually out of the box kind of an HA toolkit. We have a variety of features that put together can implement whichever kind of HA is suitable for the environment. With many of the messaging buses that we provide out of the box connectivity for, that's a built-in feature of sort of our connector. We have integrations to various, EMF, for example, typical EMS, where that's a built-in feature of the bus to be able to request a replay. That's for making sure that if you do, for example, a hot-warm scenario and one of the machines, say, went down, let's say on a two-node cluster, the warm one will just is in touch with the hot system, knows which was the last message processed off the bus, and then requests any data from that point on, catches up to real time, and then proceeds on with real time. Live view, being somewhat more of a store, actually does have a built-in recovery mechanism which essentially uses disk or other network storage devices for maintaining, again, sort of a checkpoint system where it can recover when it comes back up.
Very good. So there's a question that is somewhat related, I think, and the question is, how flexible is it to add to these systems new data types to existing databases? So I'll let the three of you decide who wants to answer that first, or if you can.
Well, let's go to the folks that are partnering with us. That they're really the ones providing the real-time capabilities.
Scott, do you want to start? Do you have an idea in terms of just adding, again, new data types to existing databases? Is there a quick answer to that? If not, we can field it at a later point.
It's not a super quick answer. I will say that it depends on what new data types mean. If they mean adding new data types to the system itself, data types that aren't currently supported, that's obviously a different question. But as a regular relational database, we support many data types today. And we've also found that there's a very large trend that was originally driven by the NoSQL systems towards these JSON data types, where there allows for flexible product development and an agile environment. Volt supports JSON in many ways that allows the developer to actually do their own data type. So if they want to create JSON architectures, Volt will support them in doing that. So I'm not exactly sure if I'm answering the question that's being asked, but we'd be happy to follow up with whoever that is and answer that in a little more depth.
Okay, I appreciate the effort. Another question for Streambase is, how many users can Streambase Live scale to? Eddie, do you want to answer that one?
Yeah, sure. Let me just complete the answer to the data type. It's actually the same one. That's really a trend. JSON does, so there are built-in lots of data types, and then you have the sort of extensible data types, which in Streambase are indeed JSON as sort of a carry anything format. We actually also have a specialization called BSON, which is essentially JSON just slightly tuned for binary data. That's common for video frames or images that sometimes are being passed along as kind of metadata for analysis. The scaling question about users. So you heard me speak earlier a little bit about typical configurations and machines, etc. So given the sort of a server, say, that had 48 cores, and one of the reference sizes that we have in production is a 48-core, 96 gig memory, and that one was designed for 1,000 concurrent users for that server. So what you do is that means 1,000 concurrent desktops, each having about 15 or 20 of these continuous queries. So that might be 20 charts, that might be 10 charts and 10 tables, doesn't matter. So those are the kind of sorts of numbers today. We achieve higher scale if for things, say, going to the internet, like retail websites that might wish to be tapping into something like LiveView. There are products out there that will essentially kind of do message bus-like distribution. So again, we will leverage any available distribution mechanisms that are typically very much like buses in the enterprise, but there are some that are emerging for consumers, for websites, and for other, you can think of the new technologies after Adobe Flash and Flex and other technologies like that have gone away. There are new ones emerging.
Okay, very good. Since we're just about out of time here, I'm going to let that be the last question and answer. So thank you for your thoughtful response, Eddie. I have just a few quick announcements. Please mark your calendars for August 27th and the next Data Science Central webinar, The Value of Modern Data Architecture with Apache Hadoop and Teradata, sponsored by both Hortonworks and Teradata. Also, as I mentioned, this event is being taped and will be made available later on today and can be found on the homepage of datasciencecentral.com in the video section. This brings our webinar to a close. I want to thank again our audience for their attendance and their thoughtful questions, and a special thank you to Pivotal and Dave Menninger for their sponsorship and insight to today's topic, and also to Scott, Mark, Jonathan, and Eddie for their insight as well. My name is Tim Madison. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on August 27th. Good day.